Hello everyone, my name is Dipankar Kendo. This is Alt Academy, and today we are going to learn about mole concept. Mole concept is a very uh, fundamental topic required for you to get a higher understanding of chemistry. So your foundation is very important. Um, that's why today I'm going to make this topic very simple for you. So this is the lesson plan for today. First of all, we'll be learning about mole and molar masses, then stoichiometry, or you may call it stoichiometry, potato, it's the same thing. Then finally, we'll be learning about reactions in a solution because in actual, like in chemistry lab, all the calculations are done in uh, solutions. Get this. Okay, here it goes. So mole. What is a mole? There is an official definition of a mole. We'll get to it later, but let me give you all um, easier definition so that you can understand it very well. So, what is a mole? So, mole is a scientific unit that is used to measure very large quantities of small entities. By small entities, I mean atom. By small entity, I mean molecule, or it can be ions. So what does this statement say? It actually says is the scientific unit to measure very large quantities of very small entities. So we have, because the atoms are very small, so naturally there are very large quantities of it. So to measure it, we said these number of atoms, uh, uh, these number of atoms, if there are so many atoms, these number of atoms we said is equals to 1 mole. Got it? They made it very simple, and we needed this because uh, we had to measure ultimately the number of atoms. So uh, like uh, like 12 pieces of anything is called as 1 dozen. So there is a specific amount. These amount of atoms or these amount of molecules or these amount of ions make 1 mole. Got it? Simple. Okay. So since we are talking about very small things like atoms, molecules, these are very minute particles, very minute. You can't even see it with a regular microscope. These are that small. So we must know how small this is. If I give you a number that the atom is this much smaller than Earth or this much smaller than uh, anything or its size, then you might not be able to comprehend how small it is. So let me give you a small example. So if this is a dust particle and this is our Earth, our planet Earth, then the difference between their sizes, the size between a dust particle and Earth, we all have seen a dust particle and we all know how big our planet Earth is. So you can comprehend the difference between their size. That is equal to the difference between the size of an atom and a dust particle. So to understand this, if you look from the perspective of an atom, you will find that the dust particle looks like the size of a planet. Now, do you understand? So now you will be able to understand, I guess, the size difference, because you know the size difference between a dust particle and the planet. So it's not the accurate size. This comparison is not mathematically true, but this is roughly the similar size. Okay. Now that we have known how small these atoms are, so now we can understand if 1 mole will contain how many number of atoms and the size of the atoms. Got it? So let's move on to the actual definition of mole. You go anywhere, you read any book, this is the first definition that pops up. The definition says a mole can be defined as the amount of substance that contains the same number of chemical entities as there are in 12 gram of carbon 12 isotope. So they are comparing 1 mole equal to the number of atoms present in 12 gram of carbon 12 isotope. This method is, they have taken the carbon 12 for reference, because they didn't know how many atoms were there, and they had measured the mass of carbon 12 atom. They had the mass of the carbon 12 atom was known. So to find something unknown, they took a reference from something which they know. So let's deduce the number of atoms present in carbon. I mean the number of mole. So the mass of C12 atom is equals to 1.992648 times 10 to the power minus 23 grams. So this is the mass of carbon 12 atom which they found physically with the help of mass spectrometer. That's how they found this mass of carbon 12 atom. And then we all know that we represent 1 mole of carbon weighs 12 grams. So ultimately, to find the number of atoms, number of molecules, sorry, not molecules, number of atoms present in this 12 grams, we have to divide it by 1 atom of carbon, which is 1.992648 times 10 to the power minus 23, which will ultimately give you the number which is 6.022 into 10 to the power 23 atoms per mole. So that's how they came up with this number, which is equals to 1 mole. And if anyone asks you what is 1 mole, the answer is 6.022 into 10 to the power 23. Got it? And this is the process, how we deduced, how we came to this number, how we came to this answer. Six 0.022 into 10 to the power 23 atoms per mole. And this number is now known as very famous Avogadro's constant. Why do we call this as Avogadro's constant? Because this thing was actually calculated by an Italian physicist and a mathematician, Sir Amedeo Avogadro, in 1811. But when he calculated this, this wasn't accepted universally. There were many critiques, and eventually this was actually utilized um, after his demise. And uh, this he died in 1856 after 5-6 years of his death. This was actually used in chemistry. So you guys should never worry how you guys shouldn't worry. You just have to work hard. You never know when your hard work will bear its fruit. See, this became a pioneering step, even though he didn't get much credit when he was alive. But after his death, he got a real respect. So we have learned this is the Avocado constant, and to get a perspective, we'll see how huge this number is. So when we write 6.022 times 10 to the power 23, I know the 6.022 times 23, this is the number. So this number is 1 mole equals to this number. This is how big this number is. Got it? So every time we say 1 mole of H2O, that is if we have 1 mole of water in a jar. Suppose let's say this is 1 mole of water in a jar. That means there are 6.022 times 10 to the power 23 molecules of H2O in this 1 mole of water. This is true for everything, not just water. Even if we say 1 mole of sodium chloride, we have 1 mole of sodium chloride in a tray. This is 1 mole of sodium chloride. That means there are these number of molecules, 6.022 into 10 to the power 23 number of molecules in this 1 mole of sodium chloride. Got it? I will cover most of the chapters, but for this session, I'll be covering this mole concept. Thank you, Nishan, for asking. Next is molar mass. Molar mass. Now that we know what 1 mole is, so roughly molar mass is how do you define molar mass? Molar mass in grams is numerically equal to atomic or molecular mass. So this is the definition of molar mass. So every time you say the molar mass uh, of let's say H2O, so this always is 1 times 2 plus 16, which is almost 18 grams. This is the round off number. Actually, it goes to 18.02, but for calculations, we use this number, 18 grams. So this is the molar mass of any molecule or any atom, which is always equal to the molecular mass. The molecular mass of H2O we have found out is 1 times 2 plus 16 is 18. So the molecular mass of H2O is also 18, and the molar mass of H2O is also 18. Okay, so let's move on to our next topic. Before moving on to our next topic, let's solve a few questions, because solving questions is very important. Ultimately, in exams, you're going to get questions like these, and you must be able to solve these questions. So let's begin. The first question is asking the number of water molecules present in a drop of water. The given volume is this much, at room temperature is. So the question is asking the number of molecules in a drop of water. Question is number of molecules. To find the number of molecules, we know that we'll have to divide the given weight by the molecular mass. So the given volume here is, we can take it approximately, it is 0.0018 grams. So you don't have to worry about that. So the given, so when we divide the given 0.0018 by molecular mass of H2O we have calculated just few seconds ago, which is 1 times 2 plus 16, it is 18. So you can see the calculation becomes very easy. 0.0018 divided by 18, it gives 1 into 10 to the power minus 4. So this is the this is the number of moles. This is the number of moles. Number of moles is always given weight by molecular mass. Now we got the number of moles, and to find the number of molecules, we'll have to multiply it with number of molecules equals to 1 into 10 to the power minus 4 into the Avogadro number, which is 6.022 times 10 to the power 23, which is 6.022 into 10 to the power 19. So this is the number of molecules present in a droplet of water. Got it? Let's solve another question. This was a question. The next question, it's same about water. The number of water molecules in 1 liter of water. So the given is 1 liter. To find the number of moles, first of all, we'll have to find the number of moles. So let me write it a little bigger. Number of moles. To find the number of moles, we'll have to divide the given quantity by the molecular mass, and molecular mass, as we know, of H2O is 18. We'll get a number, and we'll get we divide 500, it will come around 55.55 number of moles. So to find the number of molecules we'll have to multiply it with the Avogadro number, Avogadro constant. And, then we'll get the answer. The answer is D, 55.55 times Na. Got it? So the next topic is stoichiometry. Okay. So what do we mean by stoichiometry? Stoichiometry has actually come from a Greek word. Greek words. It was stoichion, which meant element, and metron, which means to measure. So what stoichiometry is? So basically, stoichiometry is the calculation of masses and also sometimes volumes, calculations of masses or volumes of reactants and products in a chemical reaction. So what is stoichiometry? Stoichiometry is a calculation of masses or volumes of reactants and products in a chemical reaction. So what does this mean? This means that in a chemical equation, suppose let me take the example of this equation, which is CH4 plus O2 gives CO2 plus H2O. This is the balanced chemical equation, and in this equation, what do we mean is there are 1 moles of methane reacts with 2 moles of oxygen to give 1 mole of, to give 1 mole of carbon dioxide and 2 moles of H2O, 2 moles of water. So this 2 and this are stoichiometric coefficient. Even this one, these are stoichiometric coefficients. Got it? So in an equation, the number of moles always balances them. These are the number of moles, and this D is for gas. If we had solid products, reactants and products, then we would have written it as S, or for solid, and L for liquid. It's and this stands for almost anything. So every time we read it as 1 mole of methane. This is read as 2 moles of oxygen. Okay, and the next formula that we must know in this is density. Density is always equals to mass by volume. Got it? So basically, now there are three ways to calculate a mole. Okay. The first way is when the number of particles is given. So you can see the number of particles, because the three ways to calculate mole is important because this will help us to uh, in numericals. The previous one was theoretical, that the definition, the stoichiometry definition, the molar mass definition, that was all theory. But this is the most important thing. This you will need for calculation, which will be coming in exams. Hi Sachin, welcome to Alt Academy. So let's start calculating when the number of particles is given. So the formula to find the number of moles when the number of particles is given is given number of particles by the Avogadro constant. It's as simple as that. So we'll understand it with the help of a question. The question is, a piece of copper contains 6.022 into 10 to the power, sorry guys, it's 10 to the 24 atoms. How many mole of copper atoms does it contain? So we are being asked the number of moles and the number of particles is given. Okay. So we all know that number of moles is equals to, what did we learn? Number of moles is equals to given number of particles by Avogadro number. Because earlier, previously, when we were solving the previous question, you might remember, we were finding the number of molecules. To find the number of molecules, we were always see here, to find the number of molecules, we were always first of all finding the number of moles, and then we're multiplying it with the Avogadro constant. Remember? So now, to find the number of moles, we'll divide the given number of particles with the Avogadro number, which is Avogadro number is 6.022 into 10 to the power 23. Therefore, it gives 10 moles of copper atom. Got it? Simple, because the formula says the given number of particles by Avogadro constant. So this is the first method to calculate the number of moles. So the next method is when we are given the mass. First method was when we are given the number of particles. This is when we are given the mass. So the number of moles, earlier you might earlier when I was solving the questions, these were the formulas. So now when you see the formulas, it is very clear for you guys. Yes. So number of moles equals to given number of substance by atomic mass. So it is same for the molecules. If we are given the mass of a molecule, so the number mole of given molecule is equals to given mass of substance by gram molecular mass. Okay, it's for atomic mass, you'll have to divide the given mass by the atomic mass. And if you are given the, if the question is asking you to find the number of moles of molecule, then you will divide the given substance with the gram molecular mass. So let's understand this with the help of a question. Question is, what will be the mass of 5 mole of SO2? So SO2 is a molecule. So first of all, we'll have to, good evening. Good evening, Pata. What will be the mass of 5 mole of SO2? First of all, we'll have to find the molecular mass of SO2. So the molecular mass of SO2 um, is 32 plus 16 times 2, which is also 32. So 32 plus 32 makes 64. So this is the molecular mass. What is the mass of 5 moles? So we know that the question is a little bit twisted. We have learned the formula of number of moles when the mass is given. Now we are being asked the mass when the number of moles is given. So naturally we'll put the same values in the formula. So number of moles uh, equals to given number of mass. We'll have to find this mass, and we know the molecular mass is 64, and we know the number of moles is 5. So 5 times 64 will give the mass. So 5 times 64 is 20, 0, 2, 5, 6, 30, 32. 320 grams. So when we say 5 moles of SO2, then we mean 320 grams. There are 5 moles of SO2 means 320 grams of SO2. Got it? So we have learned 2 methods. The first one was using when the number of particles was given. Now the second method was when mass was given. Ultimately, the third one is when volume is given. Okay. There are, this is the, so let's read the formula. The formula says the number of moles, this N means number of moles, equals to, excuse me, volume of gas at 1 bar pressure and 273 Kelvin. So this one bar pressure and 273 Kelvin is nothing but just the standard temperature and pressure. We write it as STP, which means standard which means standard temperature and pressure. Got it? So this is the new STP. Earlier we used to say 1 atmospheric pressure and 273 Kelvin. So don't get worried, because there for 1 bar pressure we use we divide the volume with 22.7, and for this, if the question says 1 atmospheric pressure and 273 Kelvin, then we'll have to divide it with 22.4. This is the only difference, the number of moles when naturally is the volume of gas when pressure is 1 atmospheric pressure and the temperature is 273. Then we'll have to find then we'll have to divide it by 22.4. Okay, and let's understand that formula with the help of a question. Question is, how many molecules of oxygen are present in 5.6 liters of oxygen at 1 atmospheric pressure and 273 Kelvin. See, I told you this is just the given uh, STP, the normal standard temperature and pressure. And the given volume is now is 5.6. We'll have to first of all uh, find the number of moles. So the number of moles is equals to the given uh, volume is 5.6 liters, and since 1 atmospheric pressure is given, we'll divide it by 22.4. So this is 5 ones are 5 by 4. This is 1 by 4 number of moles, and to find the number of molecules, naturally we multiply the number of moles with the Avogadro number, and you will get the answer. The answer is 1.505 times 10 to the power 23. Okay, so this question was very simple. Now I guess you guys understand how to calculate number of moles when, first of all, when number of particles is given. Secondly, when number of mass is given. And third, when the volume is given. Got it? The last topic for today for today's session is reaction in solution. First of all, let's understand why are we studying this topic. We are studying this topic because in laboratory we don't just mix two salts. We do so in, first we make the solution of those salts. Like if you want to react sodium chloride with any other substance, then first we make a solution of sodium chloride. We mix it with water, then we react. So that's why we must understand this. Okay. So first is mass percent or weight percent. First of all, we'll have to calculate, this is the formula for calculating mass percent. Mass percent is equals to mass of solute by mass of solution times 100. We'll naturally get mass percentage. We all know how we get percentage. That's very simple. So when we are making a solution of sodium chloride, so we'll first calculate the mass of solute. Solute in a solution is, in a solution of sodium chloride plus water. This is the solution. Okay, solution. This is the solution, this is the solute, and this is the solvent. So first of all, we'll have to calculate the mass of sodium chloride, and we'll have to divide it by the total mass of the solution, and thus we get mass percentage. Okay, it's we can take a small example like 2 grams of A plus 18 grams of H2O. So this is our solution with 2 grams of substance A and 18 grams of water. So the mass percentage of A, if we want to find mass percentage of A, then what we have to do is we'll have to divide the mass of solute, which is A, so which is 2 gram, by the mass of the solution, which is 2 plus 18 times 100, which is 2 by 20 times 100, which is 5, which is equals to 10%. So in this particular solution where we've been given 2 grams of substance A and 18 grams of water, the mass percent of substance A is 10%. Got it? Simple. Let's second thing that we'll have to learn in this reaction of solutions is mole fraction. Okay, what is mole fraction? By the term itself, we can understand that in a solution, mole fraction is the ratio of moles of both the substance. Suppose we can define it as a ratio of moles of a component to the moles of solution. Got it? So if we have two substances like A and B, then the mole fraction of mole fraction of A equals to number of moles of A divided by number of moles of A plus number of moles of B. So this is the total number of moles of the solution. Number of moles of solution. Got it? So similarly, if we have to find the mole fraction of B, what do we say? The formula will be similarly for B, formula will be NB by Na plus Nb. So the number of moles of substance B divided by the number of moles of the solution is the mole fraction of B. Got it? The third thing that we have to learn in a reaction of solutions is molarity. So what is a molarity? Simple definition of the simple definition of molarity is number of moles of solute per volume of solution in liters. As we can see, it is written in mathematically. Molarity is the number of moles of solute in a solution. In a solution, A plus B is a substance, B is water. Number of moles of solution, number of moles of solute by the volume of solution. The volume of solution in liters. This is important. This you have to understand. That the volume is in liters always. If it is in liters, then only it is molarity. So what is the definition of molarity? We can say the number of moles of solute present per volume of solution in liters is molarity. We'll learn more about it with the help of a question later. First of all, let's complete this topic. The other topic is molality. So what is a molality? A molality is the number of moles of solute by weight of solvent in kg. Now you understand, like A plus B is the solution, and the number of moles of A divided by the weight of B, only the mass of B in kg. B, by B I mean the solvent. This is the solute part of the solution, and this is the solvent part of the solution. So to find the molality, the formula is number of moles of solute by mass of solvent in kg. We'll get the molality. Got it? Now that we have understood all the definitions, the mole fraction, molality, molarity, mass percentage, let's solve a question. So the question, what does the question say? Question is saying dissolving 120 grams of urea in 1000 grams of water gave a solution of density 1.15 grams per ml. The molarity of the solution is, so the question is asking the molarity. We know the molarity. Let's decode the question in a reverse way. Okay, that's how you will understand. So what the question is asking is molarity. We all know the formula for molarity. Molarity, we can also write it as M. Okay, what to tell you, the we write molality as small m, and for molarity we represent it with a capital M. Okay, so we are being asked the molarity of the solution. So molarity of the solution is number of moles of solute by volume of solution. Okay, so volume of solution is given. So the volume is no, the density is given. Density, sorry, my bad. The density, the solution is given. Since the density is given, we can calculate the volume, because earlier we had learned the formula for density. The formula for density was mass by volume. Okay. Mass by volume. Density is given to us as 1.15 gram per ml by, sorry, let me write it this side so that it won't be covered. We'll have to find volume. So volume equals to mass by density. So the mass is in 1000 grams. In 1000 grams, this is mixed. So the mass is automatically 1000 plus 120, because this is the 120 grams of urea was added in 1000 grams of water. So ultimately the mass will be 1000. Ultimately the mass of the solution will be 1000 plus 120, which is 1120 divided by the density. So the density is 1.15 grams per ml. This is in grams. So when we divide it, make 100, and this 5 6 and 23 this is 224. So this, when we divide it, we'll get 973.91 ml. So this is the volume of the given solution. Now, we have to find the molarity. To find the molarity, we need the number of moles. So the number of moles, we know that molecular weight of urea is 60 and we are using 120 gram of 60. So the number of moles is equals to 2, because the given weight is 120 by the molecular weight 60, which is 2. So the number of moles is 2. So therefore molarity, now we know both the values of to find the molarity. We have the number of solute, that is 2, and we have the volume, which is in ml, so we'll have to convert it into liters. It will be 0.974 liter, and therefore when we add this, we'll get 2.05 moles. So option C is correct. See, the questions were pretty easy. If you if you get stuck, always try to decode from what we say, reverse engineering. Try to reverse engineer the question. The question was asking molarity. So first of all, we wrote what molarity is, and then we know the variables required to find the molarity. The variables were number of moles and volume, and we found out the number of volumes and the number of moles, and we divided it, and ultimately we got the molarity. Got it? So the questions were very simple. Hope you guys understood. The topic was also very simple. I tried my best for you. I tried my best so that you guys understand the topic very well. And that's all for today, guys. We have completed all the topics. We had completed and learned what is mole and molar mass. Mole, it is a measurement to measure very large quantities with a very small entity, large quantities of very small entities. And then we learned molar mass, which is always equals to the atomic mass or the molecular mass. Then we learned stoichiometry. Stoichiometry, we learned that it is a calculation of number of masses or volumes in a of reactants and products in a chemical reaction. And ultimately we learned and solved the questions for reaction and solution. We learned about mass percentage, and then mole fraction, molarity. And hope you guys are very clear with the topics now. And thank you. This is me, Dipankar, and this is Alt Academy. Thank you.